Good morning, I'm Marco Pradelli, and I'm at the first year of my PhD. My tutor is Professor Luca Pazzi, and I'm going to talk about my research activity that has titled Innovative Techniques and Methodologies for Embedded System Safety and Liveness. My research field is embedded system with particular focus on safety. This is a very large field, and my special area of research is model-based engineering. Model-based engineering is trying to answer to the two questions, and consists in the build of a model and allows the modeler to put attention on the behavior of the system that is under design instead of directly write lines of code. The problem is then how we can validate the model and the entire behavior, how we can represent and validate this behavior. For that concern the states of the art, most known formalism is state charts, and they allow to graphically represent the behavior and with modular constructs. But the major problem is the communication between these modules, because it's not an explicit communication, but is hidden in each of these modules, and each of one module has knowledge and can read and write information on other modules. This is clearly a problem for modularity and reusability of the software. And my research is particularly focused on Whole Statecharts. That is a new formalism under development, and it redefined the communication. Here, the components of the system are not allowed to interact and are separated, and we put the components on the top of the diagram. The only way of communication is vertical, and each component is allowed to communicate only with the whole section that represent explicitly the behavior of the system. This is a state machine that has the only task to represent the behavior that the modeler wants the system performs. In the whole section we have constrained state, so we can limit and strictly define the semantic of each state. For each state. This is an example of the semantic computation. This is a simple example regarding a traffic light. We have two semaphores on the top, and the controller has 4 states. For each state, I introduced a constraint that limits the set of global state of the array of components. For example, when the green is on the main street, I want that the semaphore on the main street is green and the other is red. This is a good way to make the behavior explicit, and each of these each part Whole Statechart is self-contained, so the system is all here. It's not related directly related with other components, and this improves modularity and reusability of the code. And this is a recursive approach, so we can assemble many part Whole Statechart in order to build a bigger system, and this is useful because each module can be validated by itself without references with other modules. So this allows to incrementally verify the system, and it should reduce complexity. I say they should reduce because this is still an open research, so the formalism is not completely finished. What is the aspect on what I'm researching are fault and command propagation in terms of path and timing of propagation, the communication between modules. In particular, if a module is shared, I have to define some rules to follow in order to prevent problems in writing and reading information or commands between modules. So, concluding, my first year of research has been focused on Whole Statecharts in terms of semantics calculation and definition and the validation of these models. For that concern future research, I will continue my work on a hierarchical composition, and I want to analyze the possibility to build the markers for timing constraints, because timing constraints are very common in embedded software. I want to implement a software tool to distribute this formalism to other people, and for that regard, real application to a real system, I participated to a call for a project from ASI, the Italian Space Agency, and we are still waiting a response for this project. It's all. If you have any question, thank you for your attention.
Just to remember that there are
also. Yes, I have two publications that I forgot to put on slide. Sorry. I will fix this problem next year, obviously. And I have also two publications submitted, and I'm still waiting for an answer.